record. It's a fraction, okay? And we said when you're looking at an integral, it's either can you break it apart and simplify it? No. Is it a rule you're supposed to know? No. Right? Then it has to be a UDU at that point, okay? And if there's not much in this question here, right? You can either be, like your obvious choices for you, either to let it be root x, right? Just the root x thing, or to let it be the entire denominator, okay? Sometimes one works, sometimes the other one works. In this case, we could go through it not working, I guess, but in this case, when you see something like this, you want u to be that whole entire denominator.
How do you know that? Like, how would
Okay, so, all right, fine. Let's say you didn't know that, okay? Let's say you just thought u was root x, right? Well, then du would have to be 1 over 2 root x, and you're going to try to do some stuff, it's just not going to work out.
So you kind of like,
Okay? No, so like sometimes you might just guess what u is, and then again, the whole thing is, can I get du? And does what's left over needs the integral to handle. All right? So if we go through this, it's just not going to work out. And since this is our first time doing a question like this, I don't want to show you how to do it the wrong way. All right? But the reason why just I know that I want to put that 1 with that is because if I derive that, that 1 just goes away. And so does the 2, actually, right? It just goes away. Cool? So when I derive that, I really just get, it should be 1 over 2 root x, but there's a 2 there that cancels it out. So it's just that. Easy enough? Now, watch this fanciness. I need a 1 over root x there to be my du. All right? And this does not work all the time with all kinds of integrals. Usually you don't want to bring in something new to get your du, unless it's like a constant. This is like a special kind of question, okay?
is there going to be one? Is there going to be one?
Probably the quiz, probably not. Maybe on the test. Extra credit, I don't know. We'll see. All right, but look. Here's what I'm going to do. Because I need this root x in the denominator to get my du, right? I'm just going to go ahead and put a root x down there. Is that okay? But if I put a root x on the bottom, I need to put one on top. And we said the problem with bringing in x's like that is you can't just move the one out front of the integral like you can with a number. If you put a number in, you can cancel it out front. But if you put a root x in there, you got to put the root x inside like that. All right, and let's just see what happens when we do all the u substitution stuff here, okay? That integral is going to become, right here, that whole denominator right there becomes u. Is that okay? That's what this is. That's u.
Why not u times du?
Well, I'm just saying that right there that I've circled is what u is. I'm not done yet. I'm saying that's u. Du is root x on the denominator and then times a dx. That's this part right here. Right?
Yeah.
I'm going to put a du at the end. So I've accounted for everything in that integral except for what? What's not in this u integral that I've started writing already? That root x. And it's in the numerator, right? So sometimes you're like, well, crap, I got a root x left over. And then so at this point you either say, this didn't work out, right? Or, can I still make it work out? So this ends up happening to be, like we have this root x left over. It's very similar to when the one we just did that had the x left over. Can I solve for root x in terms of u? I can. I got this whole equation right here. And you don't need to solve for x in this case. You need to solve for root x. And root x is going to be u minus 1 times a half. Okay? I'm going to write that down here. But if you solve that for root x right here, you get that root x has to be a half u minus 1. Okay? And I'm going to sub that in there. So we get a half of u minus 1. You're going to throw an awful lot over there. U. Is that okay? And again, this isn't magic. I'm doing a substitution, and I'm putting in things that are there, and anything that I can't sub out has to stay there. That's why that root x stayed there initially, and then I do think I either have to get rid of that, or this isn't the way to go. It just turned out in this case, we can get rid of root x if we solve for it in our u substitution. Okay, and then this integral turns into a relatively easy one. It's 1/2 the integral of 1 minus 1 over u again. Very similar to one we just did.
Okay, I don't get why du, I know du has...
Thing here. And now we just integrate this. It's 1/2 u minus ln of u. And that 1/2 is out front of these parentheses, right? And then we're just going to plug back in what u was. It was like 1 plus 2 root x or something fancy. All right? So we've got 1/2 times u, which is 1 plus 2 root x, minus ln of u, which is 1 plus 2 root x, plus c. Okay?
Can you go back like a couple steps at like